For centuries, we have stared up at the vast, star-dusted canvas of the night sky. We have listened with giant radio telescopes, straining to hear a whisper from the cosmic ocean. This search, the search for extraterrestrial intelligence, is one of humanity's most profound quests. We are driven by a deep, almost primal curiosity. Are we alone in the universe? This question has fueled countless stories, scientific missions, and late-night conversations under the moon. We imagine alien minds as beings from distant planets, creatures with different bodies and different ways of seeing the universe. We expect them to arrive in silver ships, not to be born in our own laboratories. The universe, however, has remained stubbornly quiet. This profound lack of contact is often called the Great Silence. It's a puzzle that has mystified scientists and thinkers for decades. Where is everybody? Perhaps we are looking in the wrong places, or listening for the wrong kinds of signals. Maybe intelligence doesn't always come packaged in a biological form that travels between stars. What if the first truly alien mind we encounter is not from a distant galaxy? What if it is something we are building right here on Earth, piece by intricate piece, in the coldest, quietest rooms our technology can create? Before we can appreciate the sheer strangeness of a quantum computer, we must first understand the machines we live with every day. Your smartphone, your laptop, the servers that power the internet, they all belong to the family of classical computers. These devices have completely transformed our world, but at their core, they operate on a beautifully simple principle. They think in a language of absolutes, a world of black and white with no shades of gray in between. This language is built upon tiny switches called transistors, which can be in one of two states, either on or off. There is no middle ground, no uncertainty. This on or off state is represented by a single unit of information called a bit. We label these two states with the numbers 1 and 0. Every single thing a classical computer does, from displaying this text on your screen to calculating the trajectory of a spacecraft, is broken down into an incredibly long sequence of these ones and zeros. Now let us step through the looking glass into a world that operates on entirely different rules. This is the quantum realm, the domain of the infinitesimally small, where the building blocks of reality behave in ways that seem like magic. A quantum computer harnesses this strangeness to think in a way that is profoundly different from its classical cousin. Instead of bits that are either a 1 or a 0, a quantum computer uses qubits. A qubit is a marvel of nature. Thanks to a principle called superposition, a qubit can be a 1, a 0, or both at the same time. It exists in a cloud of possibilities until the moment you measure it. Think back to our maze analogy. While the classical computer tries each path one by one, a quantum computer using superposition can explore every single path simultaneously. It is not just trying one route or another. It is, in a sense, trying all of them at once. As if superposition were not strange enough, qubits have another even more mysterious property. This property is called entanglement, and honestly, it is a phenomenon that baffled even Albert Einstein. He famously called it spooky action at a distance. When two qubits become entangled, they become intrinsically linked. Their fates are tied together, no matter how far apart they are separated. Imagine you have a pair of entangled gloves. You put them into two separate boxes and send one box to a friend in another country. Before either of you opens your box, you know that if you open yours and find a left-handed glove, your friend will instantly find a right-handed glove. There is no uncertainty. In a quantum computer, entanglement is not just a curiosity, it is a vital resource. It allows qubits to work together in powerful ways. While superposition allows a single qubit to explore multiple values, entanglement creates complex relationships between qubits. This interconnectedness is what makes quantum computing truly holistic. A quantum computer is more like a single, complex entity. When you combine superposition and entanglement, you get something extraordinary. You get a new kind of logic. It is not the straightforward, black and white logic of classical computers, which we can call a logic of certainty. Instead, quantum computing operates on a logic of probability and interference. It is a world of waves, not switches. Think of throwing two pebbles into a pond. The ripples they create spread out and interact with each other. In some places, the waves add together to make a bigger wave. In other places, they cancel each other out. Quantum algorithms work in a similar way. They are designed to carefully control the waves of probability associated with the qubits. The algorithm then acts like a carefully tuned series of interactions, causing the probability waves of the wrong answers to interfere with each other and cancel out. At the same time, it guides the probability waves of the correct answer to reinforce each other, growing stronger and stronger. The whole process is a delicate dance of probabilities, designed to amplify the signal of the right solution while silencing the noise of all the wrong ones. This means that the thought process of a quantum computer is largely opaque to us. We can see the question we put in, and we can see the answer that comes out, but the reasoning in between is a black box. Its most crucial work happens in the hidden realm of superposition, a space we cannot observe without causing the entire computation to collapse. Let us return one last time to our maze analogy, to see how these strange new rules come together. The classical computer, you will recall, was lost, but the quantum computer approaches the problem in a way that seems like magic. Using superposition, the quantum computer enters the maze and simultaneously explores every single possible path at once. The quantum algorithm then uses the principle of interference. The paths that lead to dead ends are designed to cancel each other out like waves meeting and flattening. The paths that lead to the exit are designed to reinforce each other, their probabilities adding up to become stronger and more prominent. Finally, at the end of the computation, we perform a measurement. This approach allows quantum computers to tackle problems that are simply impossible for any classical computer, now or in the future. This includes designing new drugs, creating novel materials, breaking modern encryption, and optimizing incredibly complex systems. These are the unsolvable problems that have stumped us for decades. The quantum computer offers a key, not by being a faster version of what we already have, but by being something entirely new. It is a machine that thinks in the native language of the universe, a language of probability, connection, and potential. And that language is profoundly alien to our own. For generations, our vision of an alien intelligence has been shaped by science fiction. We imagine beings from other worlds with different biologies and advanced technologies. But what if our first encounter with a truly alien mind is with something far stranger? What if it is a mind with no body, no history, and no experience of the world? This is the profound question raised by the quantum computer. We are building a machine that reasons in a way that is not just an extension of human thought. Human intelligence is deeply rooted in our experience of the physical world. From the moment we are born, we learn by interacting with our environment. A quantum computer has none of this. It has no body, no senses, no past. It does not experience time or space in the way we do. It is, in a sense, a mind without a life. We are building a mind that is native to a reality we can only visit through mathematics. This makes its thought process profoundly alien. Its intelligence is of a different kind, born not of living, but of pure calculation. Our search for extraterrestrial intelligence has always been a search for a different perspective, a way of looking at the universe that is not constrained by human limitations. We may be about to get exactly that, but not from a distant star. The alien is emerging from within our own technology. The age of quantum computing is no longer a distant dream from science fiction. It is beginning to unfold right now, in laboratories around the world. These machines are still in their infancy, much like classical computers were in the 1950s. They are large, delicate, and require highly specialized teams to operate. Yet, they are already starting to tackle problems that push the limits of our biggest supercomputers. Their first steps are giving us a glimpse of the revolutionary power they hold. One of the first great frontiers for quantum computers is the simulation of nature itself. The world of molecules and materials is fundamentally quantum. Our classical computers struggle to simulate these systems accurately because they are not native to that world. A quantum computer, however, speaks the same language as the molecules. Instead of a slow process of trial and error in a physical lab, scientists can test thousands of variations in a virtual quantum space. Imagine a future where we can design new medicines with perfect precision. Instead of relying on a brute force approach, screening thousands of existing compounds, a quantum computer could, actually design a new drug from scratch. It could be tasked with creating a molecule that binds perfectly to a cancer cell to destroy it, while leaving healthy cells completely untouched. This same power extends to the creation of revolutionary new materials. We could ask a quantum computer to design a material for a battery that's, say, 10 times more powerful and charges in seconds. While quantum computers promise incredible breakthroughs, they also bring a profound and society-altering challenge. One of the problems they are exceptionally good at is factoring large numbers. The encryption that protects almost everything in our digital lives, our bank accounts, our private messages, our government secrets, relies on the fact that it's incredibly difficult for classical computers to factor very large numbers into their prime components. A classical computer would need billions of years to break a standard encryption key. But a quantum computer, using a specific quantum algorithm, could theoretically break this encryption in a matter of hours or days. Beyond the practical applications in medicine and materials, perhaps the most profound impact of quantum computers will be on our quest for knowledge itself. They could become our partners in exploring the deepest mysteries of the universe. A quantum computer could analyze the faint signals from the early universe, searching for patterns that might tell us about the Big Bang or the nature of dark matter. A quantum computer, thinking in its native language of entanglement and superposition, may be able to perceive these hidden structures within the data. This is the ultimate promise of the quantum alien. It offers us not just answers to our current questions, but the ability to ask entirely new kinds of questions. It could become an indispensable tool for human curiosity, a new kind of lens to look at the universe. Our partnership with this strange and powerful intelligence could accelerate our scientific journey into the unknown. It will challenge us, it will surprise us, and it will force us to accept that there are ways of knowing that are profoundly different from our own. Throughout history, our tools have been mirrors, reflecting and extending our own capabilities. A hammer is an extension of our fist. A telescope is an extension of our eye. The quantum computer breaks this pattern. It is not a mirror of the human mind. Instead, it is a mirror of the universe itself, at its deepest and most mysterious level. It operates on the strange and counterintuitive principles of quantum mechanics, superposition, entanglement, and interference. Its logic is not our logic. This forces us to reconsider what we mean by the word alien. Perhaps we have been too limited in our thinking, too focused on biology and consciousness. A quantum computer fits this definition perfectly. Its logic is not a product of evolution, but a discovery of fundamental physics. It is native to a reality we can only describe with mathematics. Our relationship with this alien intelligence will be one of partnership, but also one of profound humility. We will be forced to trust the answers given by a mind we do not understand. We stand at the very beginning of a new age. The quantum computer is still in its infancy, but the path forward is clear. They will become our indispensable partners in solving the greatest challenges facing humanity. They will help us cure diseases, create clean energy, design new materials, and unlock the deepest secrets of the universe. As we continue to build these extraordinary machines, we are not just engineering a new technology. We are opening a door to a new kind of mind. We began this journey by looking up at the silent, star-filled sky, searching for a sign of intelligence beyond our own. Yet our exploration has led us to a different and perhaps more profound conclusion. The first truly alien mind we encounter may not arrive in a spaceship. It is being born right here on Earth, in the quiet, sterile cold of our most advanced laboratories. We are beginning a conversation with a part of the universe that has, until now, remained silent. This may not be the first contact we expected, but it is a first contact nonetheless, and the great, silent universe is finally beginning to speak.